Have you ever wondered why some devices charge faster or store more energy? Or when your phone battery doesn't just store an unlimited power? The answer lies in capacitors and how they all connected.
Hello everyone! Today I'll be guiding you through steps on how to solve a combined circuit, or also known as a series parallel circuit. This circuit has both parallel and series circuit components, which means we need to divide it first into simpler terms in order to before solving. So, by the end of this tutorial, you'll be able to find the total capacitance, the total charge, and also the total voltage. So, let's get started! One, identify the series and the parallel circuit. So, let's look at this given diagram. So in this paragraph, you can see that the series are much more connected and has the same current and is connected end to end. However, in a parallel circuit, it is much more complicated, as I might say, because these share the same voltage. However, it is connected into it could be 2 to 3 points. So here can see its structure. So yes, then we need to get the formula. So for the parallel and series, let's first look at the parallel combination. We see here that the total capacitance will add up. CEQ is equals to C1 plus C2 and so on. However, the potential difference or the voltage is equal. They share the same voltage. In a total charge would be the Q total would be added, just like capacitance. Next, in a series, however, it is like they share in a community. When we say they share in a community, they divide. The series combination, its total capacitance would be 1 over Q1, which means that it is getting smaller to smaller to smaller. Okay, it is divided one first. Next is the voltage would be added compared to the potential, which is the voltage to the parallel. But the total charge is equals. Here it is added, but here it is equals. So next slide. Here is an example problem for you to practice yourselves. So solve for the total capacitance, the charge, and the voltage of each capacitor. We see here an example which means C1, C2, and C3. So as I have said before, the first step would be identify which in this diagram would be the parallel and which is the series. So we can see here that C2 and C3 would be a series because this is a square. And here we need to put the given para dito malinaw. So first, we need to find the total capacitance. Since here we need to find total capacitance. So yeah, total capacitance. We need to solve first for the parallel. So in the equation earlier, parallel, if we need to find the total capacitance, we need to add. So this parallel equation, we need to add the C2 and the C3. So 15 plus 30. So here we have C2 and C3 combined. We named it as C4. So our C2 and C3, which is C4 na karon. So next would be 20 times 12 would be 240 microcoulomb. And as you can see here, our Q would be, so series, is this is parallel one, series would be equals. Q total is equals to Q1 over Q2, equals to Q2. And so here, Q1 is equals to Q4. So, would sa manatuang na sa Q1, then it could be our Q4. Next would be, we need to skip this one, guys, because the next step would be the voltage. First, for the series, we need to first solve for the series. So yes, series na to, we need to add the voltage V1 and V4. Why? Because it says here that in the series, you need to add, to get the total voltage, then you need to add V1 plus V2 plus V3. So yes, here, as you can see, baliktad na kalyot. If we need to find for the voltage, then divide Q over C, which is a charge over capacitance. So here, this one would be CEQ, this one would be V total or VQ. VEQ would be QEQ or C1. If we need to find for the V1, then 1. We just substitute the QEQ with 1 honestly. So V1 equals to Q1 over C1. So atong Q1 here na nakuha nato is 240, right? So 240 over 20. Atong C1 is 20. given so 240 divided by 20 is 12 volts. But in C4, it would be a different one since ato ang C4 is 45. So 240 divided by 45 is 535 volts. 533 volts. As you can see in this equation, the voltage is equal. Wait, in a parallel, the voltage is equals. So if we find the voltage, the parallel voltage, it would be equals. So kung saan nga itong nakuha dito sa V4 na to, or the voltage 4 would be equals sa voltage 2 and 3 na parallel or nga series. Ay wait, nga parallel. So, kung saan ito ang V4 which is 5.33, that would be the same for V2 and V3. Next is solving for the parallel. The next step, the charge of the parallel one. So as you can see here sa ato ang kuan, we need to add, to get the total charge for the parallel, we would add the Q. So what's ang equation, diba? The Q and CV in a triangle, so we need to times C2 times V2, which is charge times voltage. Ang gina na to, ang ato ang C2 is 15. So 15 times, oh my god, ato 15 times the Q2 na to, which I know 15 times the volts nato, which is here, which is 5.33. That's why it becomes 79.95 microcoulombs. While for the Q3, it would be 30. Okay, 30 man to C3 here, 30 man, and then wait. So 30 times 5.33 equals to 159.9 microcoulombs. That's the reason why like last siyang part ito to solve, guys, is we need to get first the voltage man. So yes, series first na voltage para makuha na to itong parallel. So next, the parallel would be the parallel charge. So that's it. Actually, what did we learn in this video? That the parallel has more storage, but in series it has a less storage but shared charge. Because as you can see in this kuan, the charge here is equals, but kinang iyahang total capacitance is divided, so it is less or mas gamay siya. Yeah, less storage. But combining both kanay needs a careful calculation needed, because like yeah, it could be confusing, guys, because we need to identify which one of this diagram would be the parallel and what part of this the diagram would be the the series. So thank you, guys. I would just like to share the summary for this video. It would be if in the parallel, the capacitance increases, charge adds up, and the voltage is same across all the capacitors. While in series, the capacitance decreases, 1 over C, 1 over C2, like that. It is divided. But in charge, it is the same for all capacitors. And